All right, well, welcome to Module 6, Lesson 5, Identical Triangles. This is the first lesson in Topic B, which will deal with triangles and other geometric shapes. This first one here, this first lesson in Topic B, Lesson 5, is going to provide you with a basis for identifying two triangles as identical, okay? Easy enough to look at two triangles and say, yeah, they're identical. But if you clearly want to define a triangle as identical, we're going to need to understand what a triangle correspondence is. And we'll see this terminology come up again. And need to be able to manipulate the notation and the terminology. Okay, there's going to be some notation we're going to talk about. Once you understand that, you will have the means, specifically the language, to discuss what makes a triangle unique, okay, in Lesson 7 and then beyond, okay? Just a heads up, and I'll probably tell you at the end, I think, Exercise 7 in this problem set, here, Lesson 5, Exercise 7, is supposed to be exploratory, so don't expect to get an exact answer with your knowledge after this, okay? So, yeah, don't worry about that. Okay, so here we go. We have our opening here. So when studying triangles, it is essential to be able to communicate about the parts of a triangle without any confusion. All right, and that can be confusing because triangles are, three sides, and sometimes they'll all look alike, and yeah, it's hard to distinguish. So the following terms here are used to identify particular angles or sides. Okay, so we have some words we're going to be using. Words such as between, adjacent to, and we've talked about adjacent angles like next to one another, opposite to, and the included. That could refer to either a side or an angle. Okay, the included. All right, so you're going to use figure triangle ABC to fill in the following blanks once I give it to you. And I think it's, hold on a second, and I think it's coming. There it is, ABC. All right, so there is figure ABC, triangle ABC. And go ahead and see if you can fill in those blanks. There's 7 of them there with these terms. So just give it a whirl, see what you can do. Might be a little confusing. It's your first time. So give it a try, pause, and come on back. Okay, welcome back. And whoopsie daisy. Just realized I had all the answers out there waiting for you. Sorry about that. Well, okay, here we go. Anyway, okay, so it says angle A. I just wanted to show these little pieces here. So here's angle A right over here. All right, here's how we draw that little angle symbol. It's a little arc, okay, that describes or stands for an angle. So angle A is blank sides AB and AC. And here are these sides, AB, AC. Okay? AB and AC. The answer to that would be between. Okay, makes sense. It's right there. It's sitting right between. It sits between. All right. Now angle B. Okay, so let's get rid of all that. Oopsie daisy. Don't want to do that. Let's not. Okay. Let me do. Okay, I'm not sure what I'm going to do. Okay, I'm just going to go ahead. So angle B, and here's angle B. I'll just do it in a different color. Okay, we're going to really fill this up with color here. Here's our angle B, all right? And angle B is blank to sides AB, to side AB and side BC. And here's AB, and here's BC. Okay, AB and BC. I think that last one. That one there, AB and BC. So, the answer we have here is adjacent to side AB and to side ABC. Okay, so the difference here is just in this wording at the end. Now we said angle A up here was between sides AB and AC, so both of those, okay, at the same time. But now we're saying angle B is adjacent to side AB and to side BC separately, okay? So as it stands right here, here it is adjacent to BC, and it is also adjacent to AB, okay? So that's how these two terms differ. They sounds like at first they should be the same, but the idea is, they have this here. It is adjacent to both of those. This one here is, the first one, angle A, is between these two at the same time. Okay? All right, let's go ahead. So let's say side AB now. Side AB. Let's get another color, really muck this thing up. Side AB is blank to angle C. And here's angle C. Angle C is right there. Okay? What do you think? What do you think? What do you think? I'm guessing it is opposite to angle C. Okay? It is opposite. It sits across from it. Okay? Opposite. Righty. Next we have side blank is the included side. Now this is kind of a weird little thing. Included side of angle B and angle C. Okay, so angle B, again, you can see here, here's angle B, angle C. Which side do you think is the included side? Well, of course, that is BC. Okay, BC is the included side of angle B and angle C. Okay? All right, here we go. Now 5. Angle blank is opposite to side AC. Okay, and you've actually seen this opposite idea up here in 3. So, of course, that answer is going to be B. Okay, because we had... I'm trying to find a new color here. I'm running out of colors. How about orange? Okay. So if we saw here, we had angles. So you can see angle B is, of course, opposite AC, just like angle C was opposite AB. It's because it sits across from it like that. Okay? And now we have side AB is between angles what and what. Okay, so let's look at side AB with this light blue here. Here we go, side AB again. So it is between angle blank and angle blank. That should be pretty clear. It is, of course, between angle A and angle B. Okay? All right, one more relationship here. Number 7 here. What is the included angle of line A or side AB and BC? Okay, side AB and side BC. So let's look at those two. So we have AB and BC. So now we have the question is the included angle, whereas we had included side up here. Okay, we have included angle, and again I think that should be pretty clear, and it is angle B right there. Okay, because it is included. It's also between. Okay, so there are several different ways to look at these relationships, sides, and angles. Okay, so now that we know what to call the parts within a triangle, we consider how to discuss two triangles. We need to compare the parts of the triangles in a way that is easy to understand. To establish some alignment between the triangles, we pair up the vertices. Okay? We pair up the vertices of the two triangles. We call this a correspondence. So here's that word, correspondence. All right. This is the. I don't want to take that, but this is the correspondence. Okay, when we pair up these vertices, and we'll see examples are going to help us out. So specifically, a correspondence between two triangles is a pairing of each vertex of one triangle with one and only one vertex of the other triangle. A correspondence provides a systematic way to compare parts of two triangles. Okay? So in figure 1, here's figure 1 right here, we can choose to assign a correspondence so that A matches to X. Okay, so here's A and X are going to match. Okay? And B matches to Y, B, Y. And then C matches to Z. All right? This is just one of 6 possible correspondences between the two triangles. Now you might be thinking, wow, I would have tried to flip this one over and then match them that way. You might have thought more naturally A would match with Y, and then B would match with Z, and then C would match with X here. And that's okay. You could do it that way too. I mean, that is also a possibility. Okay, but this is just one way to do it, and it's nice when they're placed this way on the paper to actually do it this way, because it kind of keeps you in order. This is the bottom one to the left. This is the top angle, and then this is the angle to the bottom angle to the right. Okay, so in that sense, it makes it easier. But you still, there are, like they said here, 6 different ways. So here we go. They show you 4 of these 6 correspondences listed below. Now go ahead and find the remaining correspondences. So go ahead and draw those, over in this area here somewhere. Okay, so draw them. Just do what they did there. If you just start with A, B, C, go A, B, C. I'll just start you off, and then. Okay, well, I'm not going to tell you how many different ways there are. Well, you know there's 6. So anyway, just match those up and come on back when you're finished. Okay, so here we are. We're back, and let's go ahead and see what you did and show you what I did here. So again, just like they had done over here, A, B, C on this side, X, Y, Z on this side. It was always like that: A, B, C, X, Y, Z, A, B, C, X, Y, Z. Then they just matched A, across here. Maybe it matched it. Oh gosh, let's probably do a different color. Let's do it with red. Matched it across there, and then it went down to Y there, and then it went to X again, and then it went down to Y again. All right. So pretty much the only thing it hasn't been paired with thus far is Z. So if we look at it, actually I just made my other. Just want to get those ready first. So in this case we can go A to Z or A to Z. All right. And then C to X, because we see C has been matched up with Z twice there, and with Y twice there. Okay, so now we're going to go with, actually that's X. One of those was Y, and one of those was X. Oh, anyway, so you can see each letter matches up with the other letters, with X, with the other letters on the other side. How many different ways? 2 different ways. Okay. All right, and then we had boom, boom, boom. Okay, so there we go. So we had that scenario, okay? Next scenario would have been that way, okay? So you had A again with Z, B with X, C with Y, okay? All right, so these are all different correspondences. So we could have actually matched up, for example, if we took another one of these, we'll just take out that last one we did here. So A matches A, Z, and then B and Y match, and then C, or B and X, sorry, B and X match, and then C and Y match. Okay, so that would have been, in that case, would have been like flipping this one that way. You can see how this would have been on top, would have matched there. And this one here would have been down right there. Okay, and you can see that. Anyway, this is the idea of correspondence, all right? There are several ways to do it. You'll probably find a way which you prefer and is easier to work with, okay? So here we go. After doing that, now we have a simpler way to indicate the triangle correspondence is to let the order of the vertices define the correspondence. Okay, so for example, the first correspondence to the first corresponds to the first, the second to the second, and the third to the third. Okay, the correspondences above can be written I'm making a mess of my thing. I can't see what was on here. Okay, yeah, it can be written in this manner. So write the remaining two correspondences in this way. Okay, so you can see right here what it's actually saying is now we're looking at this these triangles here. Let me go ahead and erase all this. Still working up here. Okay, now we have, so triangle ABC, which is boom, 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 okay, is corresponds to triangle XYZ. All right? Okay, and then this one here is triangle ABC. Again, you're watching the direction I'm going. Corresponds to triangle XZY. So I start here, 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 here. Okay? Or we could say ABC to YXZ, ABC to YXZ, okay, and on, and the next and the next. Okay, so there are two more. Would you go ahead and write those over here? All right, so again, I wrote triangle ABC, because that's what we always start with over here. Just looking at the one triangle on the left side, ABC, and then the different triangles. They're all the same triangle, but just different way to talk about them. Okay, so the next one would have been triangle ZYX. Okay, and that would have moved this way, ZYX. All right, and then the next one, the last one here, would be ZXY. Okay, ZXY. All right, and yeah, and that's it for that one. Okay, so now with correspondence in place, comparisons can be made about corresponding sides and corresponding angles. Okay, and that's what we're trying to do here. We're trying to compare, and the reason we need all of this here, all these correspondences, is because we want to be able to communicate better. Okay, and that is the most important thing. We want to communicate. You want to be clear. Okay, you want to say angle A is half of angle X, and you want to know where that is. You want to make sure. Okay, so the following are corresponding vertices, angles, and sides for the triangle correspondence of angle ABC is correspondent to angle YXZ. So complete the missing correspondences. Okay, complete the missing correspondences. Alrighty. So if you would go ahead and do that, and come on back, and I think you see what you're supposed to do. You can see right here, so vertices, there we go, we have A, whoopsie, hold on a second, do that again, I just want to get rid of this one. So now we're looking at, these two right here, A, B, C, see A, B, C, again moving that way, okay, corresponds to Y, X, Z, which goes this way, okay, so that way and then that way, all right. So now we have A is corresponding to Y, so A there, Y there, and then we have angle A, well that's vertices, yeah, vertices, good, okay, and then angle A and angle Y, which makes sense, okay, and then sides AB and YX, so that's AB and then YX, okay, so those correspond. So you can kind of get an idea of what's happening. So go ahead and look at all the B's. So you have the vertex B, the angle B, and then the side B. And then over here you have the vertex C, the angle C, and the side CA. I'm sorry, that bottom, the B was actually BC. the side. Okay, so go ahead and complete those. Okay, so let's look at our missing correspondences. Okay, so with vertex B, vertex X corresponds to it. Okay, and those are here and here. And again, of course, angle B corresponds to angle X, which is in the same place. Okay, except it's not a point, but rather it's an angle. Okay, and then of course the line BC. That line BC. Let's see. So we have BC right here. Of course, corresponds to XZ. Okay. XZ. All right. So again, we have a different kind of correspondence here. All right. So let's move on to C. Of course, vertex C corresponds to vertex Z, and then of course angle C to angle Z, and then the line CA corresponds to the line ZY. Boy, C and Z sure sound a lot. That's the reason I should use Z. Okay, so line CA or side CA corresponds to side ZY. Okay, so here we go. Here's example 1. So given the following triangle correspondences, use double arrows to show the correspondence between vertices, angles, and sides. Okay, so correspondences between vertices, angles, and sides. And again, the first thing we need to see here is we have our triangle correspondence, right? And what we see here is we have a triangle correspondence of triangle ABC, okay, moving that way, okay, corresponds to triangle STR. So this is a pretty basic one, huh? Okay. All right, so go ahead and do that. Right here, you're going to start off with the correspondence of the vertices. How do the vertices match up, etc., etc. So do a complete job. So, for example, the vertices you're going to we need a correspondence for for A, B, and C. Okay, so it's going to look like that. Then you're going to match those up, and this should not be difficult because, like I said, it is a pretty basic one. All right, so go ahead and do that, and do that for the angles, and then the